Hello and welcome. In this video, we're going to break down one of the most fundamental concepts in electricity, voltage. Let's get started. First, let's cover some quick bullet points to understand the basics. What is voltage? Think of it as electric pressure. It's the force that pushes tiny particles called electrons through a wire or a circuit. Without this push, or pressure, electricity wouldn't flow. How do we measure voltage? Voltage is measured in a unit called volts, and its symbol is a capital V. The tool used to measure it is called a voltmeter. So, when you hear about a 9-volt battery or a 120-volt outlet, that's describing the amount of electric pressure available. To make this easier to understand, let's use a popular analogy, the water analogy. Imagine a water tank connected to a pipe. The pressure of the water in the tank is like voltage. The actual flow of water through the pipe is like electric current. The analogy is simple: voltage is like pressure, and current is like flow. Look at the first diagram on the left. We have a tank full of water, representing stored energy. There's a pressure gauge, but the valve is closed. This shows that there is pressure, or voltage, but there is no flow, or no current. The potential is there, but nothing is happening yet. Now, look at the second diagram. The valve is open, and water is flowing out of the pipe. The pressure from the water in the tank is pushing the water out. This is exactly how voltage works. The voltage, or electric pressure, pushes the electric charge, causing a current to flow through the circuit. Next, let's talk about the two main types of voltage. First, we have DC, which stands for direct current. In DC, the voltage is constant. It doesn't change direction. Think of a battery. It provides a steady, consistent voltage. The graph for DC is a straight, flat line, showing that the voltage stays the same over time. The second type is AC, which stands for alternating current. In AC, the voltage constantly changes direction, alternating between positive and negative. The electricity in your home outlets is AC. The graph for AC looks like a wave, called a sine wave. It shows the voltage smoothly rising to a positive peak, falling to a negative peak, and repeating this cycle over and over. Now, let's look at the basic formulas related to voltage. The fundamental definition of voltage is given by the formula V equals W divided by Q. Here, V is voltage, W is energy measured in joules, and Q is electric charge measured in coulombs. So, voltage is essentially the amount of energy per unit of charge. It's very important to remember that voltage causes current to flow, but they are not the same thing. Just like water pressure and water flow are different, voltage and current are different. Voltage is the cause, current is the effect. A common misconception is that higher voltage is always more dangerous. While higher voltage means more electric pressure, it's not the only factor in what makes electricity dangerous. The actual danger comes from the amount of current flowing through a body. High voltage has the potential to push a dangerous amount of current, but it's the current itself that does the harm. Finally, voltage is a key part of one of the most important laws in electronics, Ohm's law. The formula is V equals I times R. This means voltage is equal to current, represented by I, multiplied by resistance, represented by R. This simple formula shows the direct relationship between voltage, current, and resistance in a circuit, and it's a cornerstone of electrical engineering. To summarize, voltage is the electric pressure that pushes electrons. It's measured in volts, it comes in two main types, AC and DC, and it's the driving force behind electric current.